Okay, I'm going to do a proof of this derivative property. And this derivative property says taking the derivative of the sum of f of x plus g of x equals the derivative of f of x plus the derivative of g of x. Now I'm going to do a little substitution here just so we can see the general pattern. And I'm going to let h of x equal f of x plus g of x. And h of a then will equal f of a plus g of a. Now, so then the derivative of f of x plus g of x can be rewritten as the derivative of h of x. Which in limit notation would look like this. The limit as x goes to a of, not f, h of x minus h of a over x minus a. And let me go ahead and color code this part here into red. And now I'm going to do my substitution, where h of x can be replaced. And I have this equals the limit as x goes to a of, on the top, my h of x, again I'm going to write in red, bringing it down, and I have f of x plus g of x. That is my h of x. And now h of a is going to be this second component here, and I'm going to subtract it all in parentheses. F of a plus g of a all over x minus a. So at this point I can do the distributive property on top, and that negative is going to go to both the f of a and the g of a. And I'm going to distribute that negative through and reorder my addition and subtraction to look like this. F of x minus f of a, oops, let me erase that, plus the g of x minus g of a, all over x minus a. And now, my property of addition and subtraction of fractions allows me to split this into two fractions. F of x minus f of a all over x minus a, and g of x minus g of a all over x minus a, and I'm taking the limit of all of that. Now, my limit property says that if I am adding two things inside of a limit, then I can actually take the limit of each item separately. So goes back to the limit of f plus g equals the limit of f plus the limit of g. So back to our limit laws, I can write this as two separate limits. And you'll notice each one of these limits represents a definition of the derivative of the respective functions. So the first limit is the derivative of f of x, and the second one is the derivative of g of x. Concluding my proof, Back to where we started. All of this started from the derivative of f of x plus g of x. And I have proven this. What does this proof allow us to do? Big, long proof, what does it let us do? So what this proof allows us to do is to take a derivative of a function term by term. For instance, if I asked you to take the derivative of a function that looked like x squared plus 2x minus 3, then I can split this into taking the derivative of x squared plus taking the derivative of 2x plus, or in this case minus, taking the derivative of 3. So it allows me to take the derivative term by term instead of having to apply any property that applies to each and everything combined. So that's the power of this property.